Ecosystem scientists like to study ecosystems as they are, to monitor flows of carbon and water and nutrients, the processes that build up an ecosystem. But to really understand how these systems will respond to global change, we also need to be able to perturb them in ways to understand the thresholds of resilience and change in an ecosystem. And one way to perturb an ecosystem is to reduce the amount of water that it gets. So here we are in a throughfall exclusion experiment. Now, throughfall is the fraction of the rain that falls through the forest canopy to the soil. And here these panels are removing 50% of that throughfall. So essentially the forest is experiencing a reduction to half its normal availability of water. And these studies here are then looking at how different aspects of the ecosystem are responding to this drought. And so here, for example, we have sensors that are measuring the growth of the tree with high precision. These are called dendrometers, and they can measure growth at weekly or possibly even daily precision in some trees, from fast growing trees. And next to them we have sap flow sensors that send little pulses of heat into the tree and measure the rate at which the heat is moving up the tree, and that gives us a measure of the rate of water flow up the tree and the water use by the tree. So with drought we'd expect the trees to be using less water, and this can be tracked through these sensors. And as we go through the forest, we can see a whole range of other measurements. And here, for example, we have a chamber that every hour or so measures the amount of carbon dioxide and methane, both important greenhouse gases, being emitted from the soil. And it does that about every hour. This chamber will move over and seal that place, and sensors will measure the rate at which carbon dioxide and methane rises in concentration, and from that you can work out the flux, the flow rate of these greenhouse gases out of the soil. And you can see a range of them scattered across this forest. And as we go further, we can see a whole range of other measurements in this area. And over here we see experiments with, we see tubes here, for example, which are called rhizotrons, scattered that look at the root dynamics in the soil. So you can put a camera in there and see how roots are growing and how they're responding to drought and to seasonal variation through these tubes. And then some really interesting experiments that I haven't seen before in other throughfall experiments around the world. Like here, they're looking at epiphytes, the plants that grow on top of on trees and therefore have very limited access to water normally. So here we're looking at epiphytes that have their rainfall removed under the panels, and epiphytes that are still receiving rainfall. And you can see how dependent are they on rainfall as opposed to, for example, getting moisture through fog or through other components. And experiments like this are happening here. We're in Alishan in southwest China at around 2,500 meters elevation in subtropical temperate forest. But there are other experiments like this all over China and also in many other parts of the world. I've seen them in the Amazon rainforest, in the Mediterranean regions, and many others. And together they give us a global picture of the thresholds and sensitivity of ecosystems to drought. And other experiments look at warming, and so overall we have a much richer understanding of the functioning of our biosphere and how it's responding to global change.